Okay, let us get into the switch 0. Able to see? Now I'll just name them. This was switch 0 outside, so I'll just give a host name of switch 0. Okay, now I'll give a command show spanning tree. Show spanning tree is telling me about the BPDU. Okay, it is telling that here is a root ID and there is a bridge ID. Bridge ID, again, it's a switch ID. It's talking about himself. So bridge ID, MAC address is this, and priority is 32769. But I told you that priority is 32768 actually, right? It is actually 32768 plus the VLAN number. You have only one VLAN here, VLAN 1. So it is 32768 plus 1. It is actually called a system ID extension, which is nothing else but the VLAN number. Why it is coming with VLANs, I'll tell you in a couple of minutes. I told you that BPDUs are sent every 2 seconds. Okay, there are some different timers are there. You forget about that. In a CCNA level, you need not know that. But there is something called as root ID, which is the bridge ID or switch ID of the root switch, and you can definitely say that he is not the root switch because the MAC address of the root ID is not matching with the MAC address of the his own MAC address, right? Next, it is telling that the cost to reach that root switch is 19. Okay, and through which port? Port number 1 or that fast Ethernet 0/1. If we have a look at the diagram, I'm here, right? He's telling that on this particular link, on the 0/1, it is somewhere, and it is with a cost of 19. Okay. So this is what it is, and it is giving the port status of each port. You can see that 0/2 is blocking, and apart from that, the 0/1 should be the root port, and other two are designated. Okay. Okay, so let us go to another switch, this switch. So I'll go to switch 2 now. I'll give a host name of switch 2, and if I give the command show spanning tree, you can see it is showing his own MAC address, and which is not matching with the MAC address of the root switch. And it too is telling that the cost to reach the root switch is 19, and it is on 0/2. So I'm in this switch on my 0/2. Somewhere there is a root switch. So let us go to this switch, and I'll give the host name as switch 1, and I'll see show spanning tree, and I can see that first of all it is not giving you a cost, it is telling this bridge is root. Okay, this bridge is root, and you can see this MAC address is exactly matching with the MAC address of the switch ID. So he himself is claiming that he is the root switch. Why? If you analyze all the MAC addresses, you will find that this MAC address is less than anybody else. It's lower than anybody else. And one more important thing is all of them are designated and all are forwarding. It will not have any root port as I have previously mentioned. Clear? Okay. Now I would like to show you, this for this switch. Okay, this switch, you have seen that 0/2 is blocked and 0/1 is the root port. What happens if I shut down this 0/1 interface? It has to go through spanning tree process and it has to elect this port as the root port at the end of spanning tree. Okay, let us go and analyze that and let us see the different port states there. So I can give a variation of spanning tree protocol, a spanning tree command given by this show spanning tree. I can look at a particular interface. I can say interface fast Ethernet 0/2 is blocking, so I would like to look at 0/2. Okay, and I forgot to tell you, but can you see this port IDs? It is the priority and the number. Can you see this? I told you, right? So these are the port IDs. Okay, fine. Now I have given a specific command. Please show me the spanning tree information about interface fast Ethernet 0/2, and he's telling that it is a blocking port. Clear? What I will do is I'll just copy this command. I'll tell you why. And I'll go to the root port now because I'm supposed to shut down that port. I'll go to the configuration mode. I'll go to interface fast Ethernet 0/1. Okay, and I'll just give a do command and quickly I'll paste this. Okay. In the configuration mode, I have given the show command, so I'm using do. Okay. Before that, I would like to start something else here. Let's say this guy is having a IP address of 10.0.10.1. Sorry. Okay, 1. Fine. And 255.255.255.0, and we don't have a default gateway, we'll keep it as it is. Okay, and this guy is having a IP address of 10.0.10.2. Now when this guy is sending a packet to this guy, this guy is sending a packet to this guy. It is not going via this, it is taking a longer route because this is blocked for user traffic. Is this clear? Okay, so what I'm going to do here is I'll send a continuous ping. I'll send a continuous ping space -t 10.0.0.2. Sorry. It is supposed to be the 10.0. And since I have sent a continuous ping with the what did I do? Normal ping is 10.0.10.2 ping. So continuous ping is ping space -t space the destination, and now it is sending continuous packets till I ask him to stop. Hopefully you are able to see some replies are coming. Fine. Why I have started this is I want to show you that during the spanning tree process there is packet loss. He will not get reply during the spanning tree. Okay, when the spanning tree calculation is going on. And now I'll come back to this switch. I am in fast Ethernet 0/2, which is I am in fast Ethernet 0/1, which is the root port, and I will shut down that particular port. Inside the fast Ethernet 0/1, I have given a do show spanning tree interface fast Ethernet 0/2 so that I can quickly put up arrow and see the things. Otherwise, I have to type so many things, right? So here I have come and I will say shut down. Down. It is in the listening state. Can you see that? It's in the listening state. See the status LSN after the root. It has become root and it is in the listening state. Now, still in the listening state. It is in the learning state. It is LRN now. LRN means learning. It is still in LRN, the third column. It is now forwarding. It is now forwarding. The packet, it is ready. It has become green. And let us go back to the PC. Can you see? You can look at the here also. Can you see this many packets got lost? This many packets got lost due to the spanning tree. Are you getting my point? And if you look at the switch here, I was repeatedly giving this command, and as soon as I have given shutdown, here I have given shutdown at this point on this particular interface number, whatever was the root port, and I am looking at interface fast Ethernet 0/1 changed to down. As soon as it changed to down, spanning tree process started, and in the blocking state they find their root port and designated ports and block ports, right? So they have found the root port and they have selected the 0/2 as the root port, but they are in the listening state now. Can you see this? I have given this command again. That's why I have kept it there so that I can put up arrow and enter. So repeatedly, this is in the listening state now. They are still in the listening state. Can you see this? I think you can see it better here. So they are in the listening state. They are still in the listening state. They are in the learning state now. It has gone from the listening to the learning. It will stay there for 15 seconds and then they will move to the forwarding state. Once they are in the forwarding state, your ping packets have reply you are getting. Is this clear? So if now I give no shutdown, I am in the same port, right? I give no shutdown now because earlier it was shutdown. I will do no shutdown. Again the spanning tree will happen. Again the earlier port, which was the root port, it got blocked. It will get opened up and this will be blocked now. So I will say enter and I'll put up arrow and I'll see this. See, it is now in the blocking state, right? But if I change it to 1 now, I want to see that this one of 1, I press enter, he's in the listening state. Can you see? Learning. It's forwarding, and by the time you will notice that some packets got dropped. Is this clear, guys? You may come you can come to the front seat, maybe better. Okay, but this is clear, guys. Okay. I'll keep it running. I'll keep the this PC running in ping. I can show so that I can show few other things here. Now this was it is taking some 30 to 50 seconds to come up. Whenever there is a spanning tree change happening, spanning tree is taking some 30 to 50 seconds to come up and make the network ready. And for those 30 to 50 seconds, your packets are getting dropped. When spanning tree was originally developed, 30-50 seconds was not a big deal. It was a very small time. But when these call centers and voice networks have come up, this 30 to 50 seconds is a huge time. If you are opening if you are opening the Gmail or Yahoo Mail, it is taking some time to open. It is slow. You will think, okay, it is little bit slow. You are talking to somebody and for 30 seconds you can't hear the voice. You will simply cut the call. Correct? For voice network, it is very essential that you get a very the network is always up, right? So since these voice networks and other things have come up, from everywhere there was some everybody was complaining about spanning tree protocol. It's very slow. Cisco developed some proprietary techniques, okay, some proprietary technologies to make the spanning tree timers little faster. Okay, like you have some which you will learn in maybe most of the things you will learn in CCNP switch. The things like uplink fast, things like backbone fast, okay, but there is something called as port fast, which you will learn now. Okay, what is this port fast? Look at this particular interface of the switch. Let's say it is 0/5, which is connected to this PC, right? Now think properly. Will there be any loop due to this particular port which is connected to an end device? What is a loop? When the data is moving out of this interface from some other side, it is coming in. Can there be any loop here? No, because it is connected to the end device. That's all, right? So this interface of the switch, you don't have the risk of forming the loop due to this particular interface. So this interface of the switch need not take part in the entire spanning tree process. Okay, so there is something called as port fast. If you implement port fast here on this particular port of the switch, what will happen is from the blocking state, it will quickly bypass the listening and the learning state and quickly move to the forwarding state. You are saving some 15-30 seconds here. Are you getting my point? It will bypass the listening and learning state and it will move to the okay. So let us now see what happens without port fast and what happens after implementing port fast. Okay, now you are getting the replies here. What I will do is I'll go to this switch. The reply is being sent by this guy, right? So I will go to this particular port of the switch and I'll shut down this interface. I'll shut down and I will quickly no shut down. And let us see how much time it takes to come up, because spanning tree will happen here. Okay, I'll go to interface fast Ethernet 0/5 if I'm not wrong. Yes, 0/5. Okay, and I will give a command called spanning tree. No, I'll not give the command now, but I will just put shutdown. Okay, it's down, and I'll put no shutdown. I have just initiated the spanning tree here. Can you see orange color? Okay, and if you see here, the packets are getting dropped here. Let us wait till it comes up. As soon as it becomes green, you will find that you are getting the replies. Okay, you have started getting the replies, and the replies are coming here. Now I'll go and implement spanning tree on that particular, port fast on that particular interface. Okay, now for that, let me talk about this port fast. This port fast you should not implement on a switch to switch link. Okay, because due to switch link there can be some loop, from one side it is coming, from other side it might come back. So you should not implement port fast on a switch to switch link. They should go through the entire spanning tree process properly so that they can calculate properly. Okay, and so that you don't by mistake implement port fast on a switch to switch link, Cisco had kept this precaution that the port fast will get implemented only in the access ports, because switch to switch links you are going to put trunk most probably. Correct or not? So they have decided that on switch to switch links we will switch to switch links, if it is trunk, even if you give port fast, this command will not work. Okay, it has to be an access port in order to get implemented. Clear? So I'll go to this switch, and I'll just give a command switch port mode access. Of course it is working as an access port only, but just that. And then I will give spanning tree. The command is spanning tree port fast. Spanning tree port fast. Once I implement the spanning tree port fast, okay, it's giving me a warning message. It is saying that port fast should be enabled on ports connected to a single host only. You should not, basically it's telling that you should not connect it to the switches, bridges, and etc. Okay, port fast has been configured on Fast Ethernet 0/5, but will only have effect only when the interface is in a non-trunking mode. Non-trunking mode. Are you getting my point? So it is, it's working now. Just let me go and check my ping packets. Yes, it is still coming up. Now I'll go, I'm on that particular interface only. I'll say shutdown, and quickly no shutdown. See, it is up. Are you getting my point? Yes, hardly there was one packet loss. Okay, so this is the port fast command. Of course, you can give a port fast command globally. You can give a port fast command globally instead of going to each and every interface. You can give it globally on the switch, and what will happen on then is that whichever is working as an access port, on those ports the port fast will get implemented. So globally, if you want to give the port fast command, you have to give in the global configuration mode, you give a command spanning tree port fast default. Spanning tree port fast default. If you give it globally in the entire switch, then all the ports which are in the access mode, there the port first will get implemented. Clear? Another thing Cisco has bought up was something called as PVST. Let me bring back my whiteboard. So there is something called as PVST. Okay, PVST, actually now it is PVST plus. Okay, PVST means per VLAN spanning tree protocol. PVST means per VLAN STP actually. Okay, so what we have learned is something called as CST, common spanning tree. Common spanning tree is something like this. For all the VLANs, you may have multiple VLANs, VLAN 10, 20, 30, 40. There will be a common spanning tree instance. There is one common spanning tree calculation for all the VLANs. So this is called as common spanning tree. Okay. Now as a result of which, what was happening, maybe if this switch is a root switch and you have couple of other switches, you will find that most of the traffic will pass through the root switch. It is compulsory. 90% of the traffic will pass through root switch. Okay, and this link will be unutilized. Now you have the link, but due to the loop, this switch is blocking this particular port. Now if somebody from this switch wants to talk to somebody from this switch, so it has to cross through this. Although there is a shorter path available, the switches will not use it. Okay, now you have VLAN 10, 20, 30, 40. For all of them it was just a common spanning tree instance. Okay, for all of them it was just a common spanning tree instance. Now Cisco has bought up one technology called as PVST. What happens in PVST? Per VLAN STP, what will happen? There will be a separate spanning tree instance for each VLAN you have created. As soon as you create a VLAN 10, okay, there will be a separate spanning tree instance. I mean to say that separate spanning tree calculation will happen. Okay, for VLAN 10, all the VLAN 10s of all these switches, a different spanning tree calculation will happen. For all the VLAN 20s, a separate calculation. VLAN 30s, one separate calculation. Now, what is the benefit? Now once for common spanning tree, for all of them it was the same spanning tree instance. Now in PVST, for VLAN 10 there is a different spanning tree instance. For VLAN 20 there is a different spanning tree instance. For VLAN 30 there is a different spanning tree instance. The root switch for VLAN 10 is calculated separately. Root switch for VLAN 20 is calculated separately. Root switch for VLAN 30 is calculated separately. All the BPDUs and other things are flowing separately. Although root switch is still the same. Here is the root switch for VLAN 10 as well as 20 as well as 30 because the MAC address is the lowest. Okay, now try to understand whether it is VLAN 10 from one switch going to another, VLAN 10 of another switch, it will follow this. If somebody from VLAN 20 from here wants to send a packet to somebody in VLAN 20 here, it also has to pass through this. Now if I change for VLAN 20, for VLAN 20, instead of this guy as the root, I make this guy as root only for VLAN 20. How can I make it? By changing the priority. only for VLAN 20. I told you that the calculation is made separately, correct or not? So for VLAN 20 I am making this switch as a root, as a result of which what will happen, you see. Now this was the original, this one root switch, and suppose VLAN 10, he was root for VLAN 10. The VLAN 10 traffic is going like this, from this guy to this guy in VLAN 10. Now I have made maybe this switch as a root for VLAN 20. How did I do that? We will see later in the configuration, but I have done it. Now when this guy becomes root for VLAN 20, this port will become root for VLAN 20, and this port will become root for VLAN 20 in this switch, as a result of which this link will be forwarding for VLAN 20, but for VLAN 10 traffic it is blocked. For VLAN 20 traffic it is open, and for VLAN 20 traffic, this somewhere here it is blocked. Now if somebody from VLAN 20 wants to send a packet to somebody in VLAN 20 here, they will use this path. Now what is happening? Some of the load of this root switch has been taken care by this switch, and earlier most of the load was on these two links, whereas this link was being unutilized. Now there is some load sharing here. Are you getting my point? So all the links are getting equally utilized. I have 3 VLANs. Maybe I will make this as a VLAN for root for 10, this for root for 20, this for root for this for root for VLAN 30. You will find that all of the links are utilizing one link or other. So this is PVST, per VLAN spanning tree, where there will be a spanning tree instance, or you can say spanning tree calculation VLAN basis. So they will have a separate spanning tree calculation for VLAN 10, separate spanning tree calculation for VLAN 20, separate spanning tree calculation for VLAN 30. Even the BPDUs will be different. Clear? So we will stop before lunch. Our PVST and RSTP will get over. You can directly move for lunch. After lunch, if I'm little late, don't worry, you just start your spanning tree. Don't do the VLAN and inter VLAN now, okay, because we cannot afford it. You can practice it later. If you have some doubt, you can watch my videos. If you have still more doubt, you can give me a call. Fine? Okay. So for that, I will create some VLANs here. Let's say I will create 2 VLANs, VLAN 10 and VLAN 20. Okay. Before that, what I will do is I would like to do VTP, VLAN trunking protocol. Quickly I will do VTP and VLANs will start. But before doing that, I have to make all the switch to switch links as trunk, right? So I'll go to all the switches. I'll take a range. You might have seen that I have used 1 and 2 on all the interfaces, switch to switch. So I'll go to interface range fast Ethernet 0/1 space hyphen space 2. I'll say switch port mode trunk. Done. Similarly, I'll go to all the switches here. So it'll take couple of seconds, it will get stable. I have make them trunk. I will just start the VTP version 2. I just have to start VTP. Oh, you don't want a VTP. Fine. So what I will do is I'll just create VLANs in all the switches. Okay, so I'll create two VLANs, VLAN 10 and VLAN 20. Okay, I'll go to the configuration mode. I'll create VLAN 10, name let's say HR, and I'll create VLAN 20 I'll go to the other switch. Now in every interface, in every switch, I have put two PCs. So what I'm going to do, one PC in VLAN 10, one PC in VLAN 20. Okay, so these are 0/5 and 0/6, I think. Okay, so let me go and I'll put interface fast Ethernet 0/5. I have already given switch port mode access, but I'll just give it again. Switch port access VLAN 10. It's done here. I'll go to the next switch. Similarly 5 and 6 is there. Okay, now what I'm planning to do is, see, that's why initially I have given it is doing spanning tree protocol again, okay, due to some changes. So these are VLAN 10 people, so I have given 10.1, 10.2. okay, let's for VLAN 20 people I'm giving 20.1, 20.2. Okay, now actually let me tell you that in the Cisco switches, in these switches by default actually PVST is running. It is not CST which is running, it is the PVST. If you want to see, you can give a command, show spanning tree summary. Show spanning tree summary. Once you give this command, you will see that the first line it is telling switch is in PVST mode. Okay, that's why I didn't tell you before, because I wanted to explain spanning tree. But you might have seen that when I have given the command show spanning tree, initially it was for VLAN 001. By default it is for VLAN 1. Okay, not by default, because there is a default VLAN 1, there was no other VLANs. So it is telling switch is in PVST mode, and it is telling root bridge for, he is not a root bridge for anybody. Okay, and extended system ID is enabled. That means that you have seen 327 priority plus system ID extension 32768 plus 32769, right, for VLAN 1. So that is actually VLAN number is also called as system ID extension there. Okay, and you will see port fast default has been enabled in this switch. I have given that command, that's why it is being enabled. And BPDU guard and other things you will learn in switch, CCNP switch. Okay, so those things you forget. And it is giving you the port status, how many are in blocking and how many are this one. Okay, and it is giving you all the information VLAN wise. Can you see this? All the informations are in VLAN wise. Now if I give the command show spanning tree, actually see, it is giving you VLAN wise. For VLAN, this is the information. For VLAN 10, this is the information, and you will get the information for VLAN 20 also. Now if you go to that root switch, we know that he is the root switch. He is the root switch for everybody, but the spanning tree calculation is happening separately. This is the root bridge for VLAN 1. This is the root bridge for VLAN 10. And this bridge is root for VLAN 20 also. Okay, and you can see here for VLAN 20, it is 32768 plus 20. Okay, and for VLAN 10, it is 32768 plus 10. Is it clear? And if you give a command here, show spanning tree interface, let's say interface fast Ethernet something 0/1, it will give you status VLAN wise. Same interface can be a now it is same, but can be a block port for some VLAN and can be a root port for some other VLAN. Okay, so without wasting much time, what I will do is, this is the root switch, right? I will take off some of the load from here. Let's say for VLAN 20, I will make this switch as the root. I will make the switch 0 as the root. How do I make it? And before that, you can actually look at spanning tree information VLAN wise. The command is show spanning tree VLAN 20. You can see, so spanning tree is going to show you all the VLAN information. So spanning tree VLAN 10, you can become little specific and you can look for only VLAN 10 information. Here you just see here that the priority is 32788 for everybody, and that's why they have gone for the MAC address. And the particular switch, whoever is the root switch, his MAC address is this, and it is less than this. Okay, it is 0009, it is 0000, so this is higher. Fine. Now what happens when we give the command? See, I'll go to the configuration mode and I'll give a command spanning tree VLAN 20 root. There, if I put a question mark here, there are two options. One is primary and one is secondary. That means, what is primary and secondary? You can make a particular switch as a root for a particular, primary root for a particular VLAN, and another switch you can make for that particular VLAN only a secondary switch. If the primary switch fails, quickly the secondary one will take over. Okay, so it is primary. Okay, now let us see what changes have happened. I'll give the same command, show spanning tree VLAN 20. Now this guy is telling that I am the root. He is telling that I am the root. How he has become the root? He has become the root because if you look at his, if you would look at the earlier, priority, it was 32788. It was 32768 plus 20, but now it has become 24596. Okay, you can just subtract it. It will be actually 2 into 4096. It will be actually 2 into 4096. That means they have reduced it by 4096 once, then again once more. So it is this one. That's why his priority got reduced for only VLAN 20. That's why he is root. Are you getting my point? Now if you give the command, same command maybe for VLAN 10. Now if you want to look for VLAN 10, you will find that nothing has changed. The other switch is still the root for VLAN 10. And he is still in the blocking, 0/2 might be still in the blocking state for the VLAN 10. But for VLAN 20, it is the designated. It's forwarding. Are you getting my point? Now just try to understand why it was subtracted by 2 times 4096, minimized by 2 times, because he wants to keep a space for the secondary root. Now I will make another switch as a secondary root. For him it will be reduced by only 4096. What will happen now? The primary root is having the lowest priority, secondary root it is having 4096 higher, and all other switches will have 4096 higher. So if this guy fails, the lowest will be the secondary root. Are you getting my point? So the secondary root, let's say that I am going to this switch and I am making him secondary root for VLAN 20. I'll go to the configuration mode and I'll say spanning tree VLAN 20 root secondary. I'll give the command show spanning tree VLAN 20. You can see that the root switch is having a priority of 24,596 and his own priority is 28,692. There is a difference of 4096 now. Is this clear? Okay. Now Cisco has bought RSTP Plus. Cisco has bought uplink fast, backbone fast, port fast, so many other things they have bought. Okay, and IEEE most of the times they will just copy the technologies what have been done. Okay, and they will implement as a open standard and push it to the other vendors. See, whatever proprietary technologies they have bought, these were only for Cisco switches to make it fast. But what will happen if you have multiple vendor switches? What about other switches? It may be possible that there are Cisco switches, along with that there is a HP switch and other switch also. Because of that, it is becoming slow. Okay, so by 1999, I think IEEE bought up a new protocol called Rapid Spanning Tree Protocol, RSTP. It was nothing but all the proprietary technologies which have been bought, which was there in the Cisco STP, and they had to be initialized by giving some command. All these protocols were put together and automatically they have put into one protocol called RSTP, and it has become a common now. And they have given an order saying that by 2001 everybody in every switch it has to get implemented. Okay, so Cisco has two implementations of RSTP. One is called as rapid PVST. That means it will be RSTP and PVST will be running side by side together. Or there is one more implementation of RSTP called as MST. Okay, that is called as multiple spanning tree. What is that? Yes, I think that's, I forgot that, but it will learn about that in CCNP only. Okay, so MST, if you have multi-vendor environment, you can run MST. MST is little bit better actually than PVST. You'll come to know later on why MST is better, but here you have only RSTP, so you don't have much about RSTP here. Only thing is that I will show you how to implement RSTP. That's one single command and that's all. Okay, nothing else is there. So what happens in, how do you implement RSTP? You have to go to each switch and give one single command. You have to go to the configuration mode and you have to say spanning tree mode. Spanning tree mode. If you put a question mark here, you get PVST and rapid PVST. There is no common CST. Okay, so if you say rapid, that means you want to implement the RSTP. Okay, done. So you can go and implement this command in all the switches. That's all. Spanning tree mode rapid. Done. Okay, once it is done, now just we will see once a demo whether we are getting packet losses happening. If it is not happening, fine. Earlier you have seen every time there is a change in the spanning tree or calculation happening, 4 to 5 packets we were losing, right? So RSTP is so fast that this RSTP calculation will happen within a second. And if STP was taking some 30 to 50 seconds, RSTP max to max might take 2 or 3 seconds or less, even less. Okay, so I have my request timeout. Why was it? Okay, we were implementing RSTP, so there was some change. Just give it, it will come up. Or maybe I'll just put Control C here and I will start it again. If I put Control C, I can stop it. Are you getting my point? And sometimes it so happens that whenever you are trying to start RSTP, the packet traces sometimes didn't support. In the older versions, I've seen that it will hang. But let's see whether it is getting supported now or not. I'll just have to check whether I have done the things correctly or not regarding VLANs. Show VLAN. (0/5) is under HR and this is supposed to be 0/5. Yes, and on this interface show VLAN. Okay, have you understood the problem? So I have not yet put them under HR or sales. I'll go to the configuration mode quickly, but I have done that, right? Interface fast Ethernet 0/5 switch port mode access, switch port access, VLAN 10. Okay, only this is enough. Show VLAN. Now hopefully my packets will start. Yes, I'm getting the packets. Now let us go to this switch and let us try to see for VLAN 10 what is the who is alternate and who is blocking and who is forwarding. So if I give the command show spanning tree VLAN 10, you can see that 0/2 is blocking for VLAN 10 and 0/1 is forwarding, right? And 0/5 of course is coming under VLAN 10. So 0/1, that means this particular one, this is blocking, and this particular 0/2 or 0/2 is blocking and 0/1 is forwarding. So the packet must be moving in this way. Are you getting my point? Now what I will do, I'll do the same thing. I'll go to 0/1 and I will block that. Okay, I will see how much time it takes for 0/2 to come up. Presently it's in the blocking state. Okay, fine. I'll go to the configuration mode. I'll go to interface, fast Ethernet, 0/1. I have to shut down that interface, but before that I would like to see do show interface, sorry, spanning tree, interface, fast Ethernet, 0/2. For VLAN 10 it is blocking, it is showing interface, VLAN wise. Now I will go and on 0/1 I am giving shutdown. It is forwarding. Can you see? Earlier it had to pass through listening, learning, and now it is directly forwarding. And if I look here, maybe one packet loss happened. One packet loss just. Okay. Now if I bring back, come back, it has come back. It was the earlier one. Okay, one packet loss again. Okay. So this is what it is. Okay, I'm getting few packet loss. I think this is not for the RSTP. This is the problem with my packet tracer maybe. Okay, but this is what it is. When you come back, I'll just give you different port states, whatever it is there in RSTP. What's the time now? It is 12:40. We'll stop here.